Hi, my name is Nur Atira and I will explain about introduction of logical implication. Definition of logical implication. If P then Q in symbolic, P implies Q. The symbol of arrow means implies two designated statement, which is the implication of Q by P. And the big arrow is notation for logical implication.
My name is Nur Alia Aisyah binti Muhammad Rawi. Now, I will explain about truth table. So we know there are two ways to define logical implication. One of them is the truth table. There is also another way, which is the rule of inference. Okay, so today, I will go through the truth table. If you want to know if a statement has a logical implication or not, the implication should be in tautology, which means all true. What if we do not get tautology? That means it does not logically imply. By looking at the example, we can see that all of the final values are 1, which means it logically implies.
My name is Salim Rahman. The introduction of rules or inference is by using the list of rules, we can easily analyze the logical implication.
For the first example, the question is to construct a truth table to determine whether x and negation y logically implies negation x or negation y. So first, due to the question only giving us an expression, we need to identify which of the following is hypothesis part and the conclusion part. Here we could see that x and negation y is our hypothesis, while negation x or negation y is our conclusion. Next, we assume that 1 is true and 0 is false, and then we need to find the truth value of x, y, negation x, negation y, x and negation y, and lastly negation x or negation y. So now, we need to find the truth value of each column and identify the type of proposition, whether it is a tautology, contradiction, or contingency. And if we get the tautology or all the truth value of the last column are true, we could say that the two expressions are logically implied. Now, for the first column, which is x, we will divide into two parts of 1 and 0, or we can say that it's true or false. So, we will have 2 zeros and 2 1. For the second column, we only need to reduce or divide it again. So, for the column y, it should be 0, 1, 0, 1. There are only two variables we have, and then we make a negation x, which is 1, 1, 0, 0, and for negation y, 1, 0, 1, 0. Fifth column, which is x and negation y, we take from the first column and the fourth column, so we get 0, 0, 1, 0, and we assume variable a for hypothesis. For the second last column, which is negation x or negation y, we take from the third and fourth column and we get 1, 1, 1, 0. We also assume variable b for the conclusion. For the last column, a implies b, we could see that all the truth values are true, or we call tautology. Therefore, we can conclude that since the truth value of the final column is tautology, which is all true, we can say that x and negation y logically imply negation x or negation y, or we could also write it in symbolic form.
Now, let's move into the second example. Given question is, construct a truth table to determine whether not P or Q and P and Q logically implies to P and Q. Before answering the question, we must first create a table. Next, list down all of the true value for P and Q. As we learn in truth table, 1 is referred to true, meanwhile 0 is referred to false. Following P and Q, we list down the true value for negation of P. To make it easier to understand, we can assume that not P or Q and P and Q as A and P and Q as B. After that, we move on to find the true value for all of the elements in brackets, and so A and B. At the end, we can see that the last column have all its true value is 1, which is true in tautology. Therefore, A is logically implies to B.
Rule of inference, example 1. First, I choose premise 2, not P implies Q for the first step, and Q implies S, which is premise 3 for the second step. Then, apply the law of syllogism for steps 1 and 2, which is that when not P implies Q and Q implies S, I will get not P implies S. Next, I take premise 1, P implies R for step 4 and change it into a contrapositive not R implies not P. Lastly, I apply again the law of syllogism for steps 5 and 3, which is that when not R implies not P and not P implies S, I will get not R implies S.
The argument says Rita is baking a cake. If Rita is baking a cake, then she's not pressing her flute. If Rita is not pressing her flute, then her father will not buy her a car. Therefore, Rita's father will not buy a car. The question is asking to declare all the relative propositions in the argument above using symbol P, Q, and R. From that, we need to identify the primitive proposition. We can say that P is Rita is baking a cake, Q, Rita is practicing her flute, R, Rita's father will buy her a car. While question B asks to write the premises using symbols, we can write it as Rita is baking a cake as P. If Rita is baking a cake, then she is not practicing her flute as P implies negation Q. If Rita is not practicing her flute, then her father will not buy her car as negation Q implies negation R. Therefore, Rita will not buy a car as negation Q. Question C is asking to prove validity of the argument using rule of inference. First, write P implies negation Q as premise 2. Second, negation Q implies negation R as premise 3. And if we go through the formula, we can use law of syllogism to simplify it, and we will get P implies negation R. Next, write P as premise 1 and use modus ponens to simplify it, and we will get to prove that the answer is negation R.
The statement is logically implies only when all the true values are true, which is referred to tautology. We can prove the true value of a statement using truth table and rules of inference. Logical implication involves three components, which is a predicate, a conclusion, and a transformation between them. As an action, implications play a key role in logical argument. If an implication is known to be true, then whenever the hypothesis is met, the consequences must be true as well. Thus, by using symbols to represent relationship between the elements of an argument and using rules, we could draw inferences about those elements.